The best time to be a math scholar is all the time. Hey, this class just got their quizzes back, and I think 6 of them were math scholars yesterday. So let's give all our scholars a round of applause. All right, we are learning about 8-4. We're starting into factoring, and we're going to learn what a GCM is, a greatest common monomial. So here's a little bit of vocabulary to jot down. If I ever refer to the word factoring, what I'm talking about is backwards distributing. So you'll be starting with a polynomial that's all the way distributed out and all the way simplified, and you'll be actually working your way backwards and try to see what the problem looked like before they foiled or before they distributed, which is so crazy. We spent all this time foiling, and now we're going to learn backwards foiling. And then if you hear me say GCF today, or sometimes I slip up and say GCM, it's the greatest common factor, or greatest common monomial. That's why I slip up and call it a GCM, but they're the same thing. It's the greatest common monomial that you can pull out of a polynomial and factor it out front. So I'm going to show you a quick example so you know what in the world I am talking about. So let me say that I want you to factor 2x plus 6. I want you to factor 2x plus 6. What that would look like is thinking, I have 2 terms, this is a binomial, and thinking, what is the largest number I can divide out of each of these terms? Do you guys know the answer to that question?
3.
It's not 3. We have a term here and a term here, and the question is, what's the largest number I can divide out of each of those? It's a 2. And what you're going to do with that 2 is you're going to put it out front, and you're going to think about what would it look like if I kind of undistribute that 2. So you kind of do this. 2x divided by 2 is x, and 6 divided by 2 is 3. So this is what the problem would look like if I kind of undistribute that 2. Make sense? And do you know how you could check your work to see if you did it right? Redistribute it. Yeah. So this is what factoring looks like. Factoring out a greatest common monomial. Greatest common factor. All right. So the question is, what is the greatest common monomial in this expression? This is a trinomial. So you want to look at all 3 terms and think about the largest number you can divide out of all 3 terms. Austin, what do you think? It is 5. Great. So the greatest common monomial is 5. Now, since we're brand new at this, we are actually going to put this into vector form. We put the greatest common monomial out front, and then we put a big old empty set of parentheses. You're going to have 3 terms inside the set of parentheses for this to backwards distribute properly. Ken, do you know what would be in here? Good job. You're close. There will be an x, but you need a number here. And then this one? Good. And this is actually what it looks like in factored form. I'll hear people think, we don't have to do anything more. You already did it. You already factored it. You pulled out the greatest common factor, plopped it out front. If anything, if you want to check your work, you could redistribute. Okay. What is my greatest common monomial in this expression? The number that can go out front. Very good. We're going to go with the 2. We're going to put it out front. That would answer the question on what the greatest common monomial is. But then we're going to need 3 terms in here. I know one of those terms will be gone when we divide by 2, but we'll need a 1 there to keep it a trinomial. All right, Jagger's my helper. What's going to go right here? No. Because you need to think 2 times what is 12x squared? 2 times what is 12x squared? Good. 6x squared. 6x squared. Okay, Brad's got my next term.
Yeah, Brad.
It is 3x. And then my final term. This is what's weird. If you take a 2 and you divide by 2, don't just say, it's gone, I'm done. If you would go to recheck this, you'd be missing the whole term. So you do need the 1 there that some students are saying. Good job. You need to have the 1 if everybody's gone. All right. We're on the video right now. We've got negative 3x to the 7th and 2x to the 8th, and I heard some people throwing around the idea of maybe pulling a decimal out. I should write this out. You will never have any decimals. No decimals for your greatest common factor. But negatives would be okay. You could have a negative number for your greatest common factor.
Let's get a negative.
Well, I just think negative 3 and 2 just don't have a number in common that we can pull out front. What were you going to say? One as far as the number, but you can pull common variables out. So that's what we're going to focus on pulling out. If I have 7 x's in this term and 8 x's in this term, how many do you think we could stand to pull out front? 7. You can pull all 7 of the x's out front. So when I divide this term by x to the 7th, you know who's left? Negative 3. Because x to the 7th times negative 3 is negative 3x to the 7th. And then when I pull x to the 7th out of this, do you know what will be left? Good. That's what it would look like.
Okay. So first you gotta take your marker thing, and then we're gonna see you could go to 12 and 12. You could go 12 into both of these. One time for that one, you know. Yeah. So
I don't think you can divide a 12 out of 42.
I don't either.
Do you guys have a suggestion on what he should divide
Yeah,
out?
class. What should we do?
Something bigger. Dylan's got it.
Yes, 6. So you're gonna divide these both by 6.
So 2 would work.
Okay. So what's next, class? Yeah, we'll get 2x plus, and I think that would be 7. 7y.
Good job. Pass the marker on to Gary.
Yes, Gary.
All right, we chose to do this one as a class. The question was, should I pull a 4 out or should I pull an x cubed out? And I said both. You should pull out everything you can. That's why they call it the greatest common monomial. Most thing you can. So you're going to pull a 4 out, and you're going to pull out an x cubed. Now, can you guys tell me what would be left in my first term? And what about left in my second term? Good job. Yep. Just a 6, because 4x cubed times 6 is 24x cubed. All right, I think I'm just going to send up 8 people to do this one, okay?
Oh yeah.
So I'm going to do the method of checking to see if you guys got this right. So is 5n times 3n squared going to be 15n to the cubed? Yeah. And is 5n times 5 going to be 25n? And if you ever check your work, like on your quiz, you can just put a big check mark to denote this is me checking my work. Okay? So I'll do that to people in my notes now. But this is the answer right here. We're on the video right now. All right, let's get some more board buddies up to give this one a try. All right, so I circled the answer my board buddies put up, but here's how I'm going to check their work. Is 3m squared times 3m to the 5th going to be 9m to the 7th? And is 3m squared with a negative 1 going to be negative 3m squared? Okay. Now, I did have a question. What if you pulled out like a 3m instead of a 3m squared? Unfortunately, it would be wrong because you wouldn't have pulled out the most you can. It's called greatest common because you want to pull out the greatest amount that you can. So yeah, you want to pull out 3m squared. All right. Board buddies. All right. Hey, people in the video, we did have a little bit of troubles on this one. You don't want a w with the 5. You don't want any number with the w cubed. So you do not want a number here, and you do not want a variable here. This answer is correct, so just check your work there. I definitely don't want the class to end without showing you this problem here. There's one on Varsity Learn very similar to this, and I thought people could be confused because suddenly you have a whole slew of variables.
Oh my.
The instructions on Varsity Learn on this particular problem is factor the right-hand side of the equation. What do these two terms on the right-hand side of the equation have in common?
A.
A capital A, easy. But what would be left in the parentheses?
X.
Well, there will be an x here, but I need to have two terms.
1.
1 plus x. Does that make sense?
Yeah.
Do you think you could do that all by yourself on Varsity Learn?
Yeah.
All right, then let's do our graduation question.
Yeah.
Go ahead and see if you can factor this. If you have trouble reading the computer font, this is a trinomial. All right, so there's a lot of chat. We have 3 terms. What do all 3 terms have in common? It's just an x. Not all 3 terms have a p, but all 3 terms have an x. So when you bring the x out, you still need to be very conscious that you still need 3 terms. Okay? What would be term 1? A p, because I divided out the x. What would be term 2? Yeah, that's the tricky one. And what would be term 3? That's tricky too. You're going to still have the p squared, but you removed one of the x's. So it would be xp squared. Isn't that weird? This was a hard graduation problem. Did anybody manage to graduate though?
Yeah.
Quite a few. So your homework, I'll just write it up here, is called 8.4 Greatest Common Factor Varsity Learn. It should show up on the calendar, maybe on tomorrow's date. Thanks for watching the video.